Hello and welcome back to our AI series. In this episode, we're going to start our look at the EQS system, or the Environment Query System. So in this episode, I'm going to go through introducing what the system actually is and what it does, and how to get started by generating some points on it. So let's get started with EQS. So I want to get started with EQS. Now, EQS is an Environment Query System. It basically allows you to have your AI scan the environment and score positions in that environment based upon some conditional tests that we put onto it. So, for example, it makes it able for our AI to hide from us, to look for certain spots, to see what's most advantageous, and so on and so forth. And we can do this via the EQS system. So let's go ahead and create this for our AI character. I'll make a new folder here just for EQS, and we can talk about this today. So the EQS is created by, first of all, going to artificial intelligence and creating an environment query. Choose this, and we do EQS demo, we'll call it. This is the query, and from first inspection, it looks a lot like the behavior tree that you're used to in doing with AI. However, it's very different because what you do is you drag from the root here, and it asks you to create a generator. Now, generators are going to spawn in a load of dots around their environment. These are called items. So when you see in here the word items, it's usually referring to those individual dots. So, for example, if I do points in a grid, like so, this will generate a grid of 1,000 by 1,000. So it's 500 half size, and a grid, a item at every 100 units. And this is going to be generated around the querier. So to help demonstrate this, we're going to use something called an EQS Testing Form. Now, this is an actor that they've provided for us in the engine to help us do these sort of little tests to work out what's going on. So you can go up to Blueprint Class and search in here, EQS, and you'll choose EQS Testing Form. Let's open this up, and we'll name this one EQS Tester. And we just drag it into our scene, and it just looks like a pawn capsule. That's all it does. But what this can do on the right hand side details panel, if you scroll down, you'll see you can enter a query template, and you can choose the one we just made. And here you can see that grid of items that I was referring to. Now, each one of these items will get scored and or filtered out based upon tests that we can put onto the query. You can also change their spacing, their elevation, and how they are projected onto the environment. So let's go through some example tests here. I'm going to go open up my demo. And you can see here, right-click to add tests. So I'm going to do that, right-click, add test, and you've got a number of tests in here. Now, some tests are used more than others, such as distance, dot, and trace. So let's go through how and what each one of these do. So let's go through distance first of all. So distance, as you can see here, has some settings on the details panel. Now, a lot of these settings are the same for each test. So once you learn in one place, they are the same in all the other places too. So you've got the test purpose, where you can filter, and score what you want to do. Filter basically means it's going to cut out some of the items, ones that aren't relevant, and score means it's going to give it a score. Test mode, in this case, is working on the distance settings. So here we're going to do distance of 3D or 2D or distance in height. I'm going to keep it as 3D. And the distance to the querier. So this is referring to each item. So each item is going to measure the distance between it and the querier. And over here you see a filter. This is for the filter setting. If I change it to score only, it disappears. And vice versa if I change it to filter only. So on here on the scoring section, you change how it gets scored. So at the moment, this is a linear scoring thing. So basically, the ones further away, a greater distance, will have a higher score. So demonstrate that. Here we are. And you can see it's color coded as well. So the ones in the middle, this one is called 0.11, whereas the ones on the edges are set to 1 and closer to 1. Now, if I change the scoring equation here to inverse linear, it does the inverse of that. So the ones now closer to it are now 1, the ones further away are closer to 0. And you've also got these square and in square root, the inverse of the square. And this gives you this curve going on here. So basically, the scoring system is more weighted towards the back end there. Okay. And the inverse square or square root is the same, but in reverse. So that's how scoring works there. So let's say I want them to hide from my player character. Okay. So let's say we're generating these dots around here. We want it to pick a spot that is furthest away from our player character. Now at the moment, this is only generating around our querier and each item. And that's because on our distance 2 here, we've got this querier context. We need to make our own context for the player. So we're going to go and do that. Let's right click in here, blueprint class, and you're going to search for the word context and create a context blueprint base. And we'll call this one context player. Now, the interesting thing about this is that we need to return the player character, but we can't do that when we're in editor mode because the player character is not playing. So how do we accomplish this? Well, first of all, let's talk about how contexts work. A context has 4 functions that we override. We've got provide actor set, location set, single actor, or single location. So we're either sending over an array or a single item. We're going to do a single item because we've got a single player. But as I said, if I do get player character, that doesn't really work because the game isn't running. So therefore that function returns nothing. So what we're going to do is make it work for the player start instead whilst we're testing it before we go into the actual game. So for that, I'm going to do get actor of class and just choose the player start. And put that then instead for now. When we go to test it out in actual gameplay, we want to swap these 2 around. Okay, so if I go back to my demo and go to the distance 2, I can change that now to my context player and save that. So now you can see they are scoring based upon their distance from this player start actor. So inverse square means, or square root rather. No, sorry, this is square, not inverse square. This is square. So the ones further away are going to score higher, which is what we want. We want them to hide from us and get as far away from us as possible. So if we go to our demo, I'm going to change it back to linear. Like that. And there we go. Okay, so now we've got this going and choosing the spot that is furthest away. So at the moment, the winner is going to be this one over here, this little one over here. But let's go make sure it picks one that is hidden from our player character. So I want to choose the trace test now. Go add test and do trace. And this does a line trace basically from each item to a target. And I'm going to do a filter only for this one. So I'm going to change that to filter only. And on the trace here, we've got trace data, which we can expand upon and have a look at. This is where you can change the different trace channels you want to use, so visibility, camera, or your own custom ones. What shape you want to do, line, box, sphere, capsule, the ones we're used to using. Line's fine for me. And we're going to do only blocking hits, yep. And trace from context, no, on. And the context here is going to be the player. Okay. Now, the ball match means that the trace must, if it hits, then it means it gets filtered out. So the ones that are hiding from the player, like this one, aren't filtered out. If you want to flip around the other way around, in this case we don't, but if you do, you just turn off ball match and it'll be the other way around. Okay. So let's go back and talk about what we're seeing here with the ball match being turned on. So on ball match, it makes sense for this one here to be hiding because that is kind of hiding from the player. But these ones don't make sense. Why is that happening? Well, this is happening because the line trace is coming from the center of these items, and therefore it's clipping with the floor that's slightly risen in front of it. So what I need to do is add a little offset to the height of these items. So I'm going to go to the generator, and up here in the generator you'll see projection data. We expand this open, go down to post projection vertical offset, and we're going to add a value to this. And you can go to like the waist height, which should be roughly about 80 if you want, or you can go to head height if you want, about 120, whatever you like. That's the height you're going to do. And now you can see they're off the ground a lot more. And now you can see this one is the only one that is valid hidden from the player character. And if I were to push this way around, you'll see that these are all hidden too. Okay, so that's not too bad, but let's make it pick one that is closest to it, because we don't want it to pick this furthest one. We want it to run to the one that's closest to him. Yeah. So we're going to add another distance node to our demo here. So just add another distance. But this one is going to the querier, and we want to score it based upon how close they are. So I'm going to change the scoring equation here to inverse linear and score only. I'm going to save that and close this down here. So now we can see how the scoring is working. These ones here are going to score higher than the ones that are further away, because it's closer to him to run to, and it's still hidden, therefore it's not too bad. So now we've got that set up, how do we actually use the EQS? Well, the EQS can be called in two ways: via blueprint, which I'll do in another episode, or by a behavior tree, which is what we're going to do in this episode. So let's go over to our behavior tree that we're currently using for our NPC. At the moment, our NPC is doing this move to location randomly around. Okay. So what we're going to do, instead of doing that, I'm just going to drag out on this again from a selector here, do a sequence. Let me just move this all along. Or better actually, target actor, we'll put that, we'll make it over here. So rather than chasing us, which is what this chase selector is doing, we'll do another one. And that'd be a hide selector. Okay, and on the hide, not selector, so sequence. Sequence, and just do it again. Hide sequence, there we go. Okay, right. So we've got the hide sequence there, and we do run EQS query. And this, you have to set up two things. You have to set up the query you want to run, which you can do over here on the right, query template. Just choose the one you want. And then we've got the blackboard key you're going to put the resulting into. And the result is a location, so we'll do target location in this case, that vector. And you also get this run mode. And the run mode here you can change from single best item to random item with best 5%, or random item with 25%, or all that match. So you can add some really nice randomness to it, which is really quite cool. There's also where you put in things like the configurations for the query that you want to do. So like parameters you may want to put in, you can do that here too, but we're not worried about that here for this episode. That's for the future. So this will run the query, and then we're going to take it to move to that target location, like so. Okay, so he will do this now if the target actor has been set. So if he's seen me, he should hide. So let's go back to that context and replace that with our player character. And now if I push play and he sees me, he should be responding to me. Does he not see me? Hold on. Let's go back into here. Okay, hide sequence. Target actor, none. It's because he's turning away from me. Therefore, he's hiding, but then he's turning away and not seeing me. So there you go. He sees me. So I just want to tell it to, on the behavior tree, to not abort the hide sequence. No, it shouldn't be aborting both either. Tell you what, we'll just take it out from here for now. There we go. Just so we can see it working properly. Oh. So now it's going to run and hide for me. There we go. You see he's sticking to the wall because he's picking points that are closest to him. Now you can debug EQS as well by hitting the apostrophe key. Oh, not that one. I'm looking at the wrong one there. There we go. And if I hit 3 on my number pad, you can see his EQS. So you can see the scores, you see what ones are relevant to him. I can turn this back on here. Oh, there we go. You can now see what's going on here. And it will highlight which one he's chosen as well. So when he moves here, it will highlight which one he's chosen. There you go. He hadn't seen me. There you go. Okay. And that's an introduction to EQS. So there you go. We now use EQS as a basic tool to make our character run away from us when he sees us. So in the next episode, I'm going to go through some more of the tests that we have and explain what they do and how they differ from each other and how they could possibly be used. And if you want to catch the next episode right now, head over to patreon.com/Ryan Laley, where you can donate just $1 and get access to all my videos early before everyone else. Thank you for watching. Make sure you subscribe to the channel, and I'll see you next time. Bye, everyone.